So this is lesson 3.7a, the elimination method in elementary algebra. The elimination method means that we have two variables, two equations, a typical system of equations, and elimination means we're going to eliminate one of the variables. And the way we're going to eliminate it is we're going to make sure the sign of one of the variables, and this one is already that way, are opposite. They both are y's, the numbers, they're opposite in value, and the number in front of the y is the same. In this case it's a 1, or there's nothing there because it is a 1. So it could be a 4 or a 2 or whatever, as long as they're the same. So then what you do is you just add these. So we add the x's and get 2x. We add those and they get 0, so they go away. Add those and we get 6. So now we have 2x equals 6, divide by 2, and we get x equals 3. But this problem up here is asking for x and y. So now we take one of these equations, doesn't matter which one, and we plug the 3 in and we solve for y. So we subtract 3, and we get y equals 1. So my answer for this particular problem is 3, my x value, 1, my y value, and I'm done. So let's look at example 2. X plus 2y equals 4, and x minus y equals negative 5. Alright, so I don't have the same signs here. I've got a 1 in front of an x and 1 in front of an x here, a 2 here and a 1 here, so I'm going to ignore those. These already have 1's in front of them, so that's good. The only difference is this doesn't have a negative in front of the x. That's got a positive, but they're both positive, and I need one to be a negative, so all we do is switch the signs of everything on that line, and now we add these, and those go away. 2y plus y is 3y. 4 plus 5 is 9. Divide by 3, y equals 3. 9 divided by 3 is 3. Alright, now I take one of my equations. Let's take x plus 2y equals 4. Doesn't matter which one. And I'm going to plug 3 in there for my y. X plus 6 equals 4. Subtract 6, x equals negative 2. So, negative 2 is my x, and 3 is my y. Make sure you put them in that order. The negative 2 first, because that's the x, and then your 3. Alright, so let's look at example number 3. So for example 3, we have 2x minus y equals 6, and we have x plus 3y equals 3. Alright, do you see a problem here? We don't have the same number here, nor do we have the same number there, but that's okay. We're going to make them the same, because it'd be nice if we had a 2 in front of here, then we could add those together and cancel them out. In fact, we need a negative 2 here, right? So what we're going to do is we are going to multiply this entire equation by negative 2, so that we get a negative 2 in front of that x. So let's do this. Negative 2x minus 6y equals negative 6. So that is my new equation for this. I can do that. It doesn't change the value of anything. It's kind of like taking 1/2 and making it 2/4. It's kind of opposite of reducing. So let's go ahead and write our 2x minus y equals 6, our top equation. And let's write our bottom equation here, minus 6y equals negative 6. And let's add. So we add those together and we get 0. We add negative 1y plus negative 6y is negative 7y. And 6 plus negative 6 is 0. Divide both sides by negative 7, and y equals 0 or negative 7, or y equals y equals 0. Any number, anytime you have 0 in the numerator, your answer is 0. Now we're going to go back up here and plug 0 in for either one of the problems. Let's take the second one this time. So what number goes in there that we can add 0 to get 3? 3. So when x is 3, y is 0. And I'm done with that one. So let's jump to example number 4. And number 4 has 2x plus 3y equals 1, negative 1, and 3x plus 5y equals negative 2. Alright, here's the problem that we have here. I not only don't have the same number in front of my x, I don't have the same number in front of my y, and I can't get this to be a 3, and I can't get this 3 to be a 2 like I did in the other one. I mean, in one I had example 3, I had a 2x and a 1x, and I just multiplied everything by negative 2, and I had 2's. I can't do that here. So what I do is, if I can't make this a 3 or this a 2, I multiply both of them by a number that will give them a common factor. So if I multiply that whole thing by 3, then 3 times 2 is 6. If I multiply this whole thing by negative 2, then this will give me a negative 6. So I'll have a positive 6 and a negative 6, and my x's will cancel. So let's see what we get here. 6x plus 9y equals negative 3. Negative 6x minus 10y equals positive 4. Negative 2 times negative 2. Now I'm going to add these. And when I add these, my x's disappear. So those go away. 9 plus negative 10 is negative 1y. Negative 3 plus 4 is 1. Divide by negative 1, divide by negative 1. Y equals 1 over 1, which is 1, and we have a negative there. Now I'm going to take my negative 1 and plug it in any of those equations. It doesn't matter. In fact, what I've got here is 1, 2, 3, 4 different equations. It doesn't matter which one you plug it into. So let's plug it into the bottom one. So 3x plus 5 times negative 1 equals negative 2. 3x plus negative 5. 5 times negative 1 is negative 5. Negative 2. I'm going to add 5 to both sides. 3x equals 3. X equals 1. So when x is 1, y is negative 1. I got from there. And that's my answer for problem example number 4. And let's continue on to another video for the next couple examples, and then we'll be done.